Good afternoon. Hi. Yes, that's better. Okay, I like that. Thank you. So let's get started. My name is Paula J, as you see. And, well, you pronounce it Januszkiewicz. That means I'm from Poland. And what I do for a living, it's cybersecurity. I do penetration tests for various customers. And we also deliver workshops. But what is my hobby? It's still the same, my job, yeah, so cybersecurity. From the background perspective, I've got access to the source code of Windows, but unfortunately to 99.999% of it, which means that the rest is the most interesting part and not many really people have access to it. Therefore, what do we use it for? Is for the research that I would like to show you today. Yeah, so this is going to be the subject. We're going to be talking about credentials and the way how we store them, and a couple of important things you need to know about them. If it's about my company background, I work for the company that is called Secure. Technically, this is the company that I established. In October, we celebrate 10 years this year, so this is not too bad. And we are placed in 4 locations: Poland, New York, Dubai, and Switzerland. So this is the set. It sounds very serious, but we are actually a very small team of people doing various researches in cybersecurity. It's good to see you. Thanks for coming. And hopefully everything is going to be interesting for today. Couple of words regarding the speaking background. I happen to speak also at Microsoft Ignite, which was not really long time ago, and also at conferences that are called Black Hat. Do you recall as well? I guess you do, because you are here. So security is important. So this is where we share our research. Okay, guys, so let's get started. What are we going to be talking about today? Well, very simple thing. Yeah? So we're going to be discussing what are the credentials in operating system, what's the background for them, basically where they are stored and how they are used, and if really those what we use are credentials. Yeah? So it's important to start with a little bit of a definition. Yeah? And the definition sounds like it's a set of data that allows other party to believe me who I tell who I am. Yeah? So we didn't copy it from somewhere. Yes, it's actually our team's definition of credentials, which it kind of makes lots of sense. Yes, because when we do have in Windows something that we call cache credentials that we all define, let's say, are those really credentials, or this is just some cache logon data that we are not able to reuse at any point? So it's important to know what and where do we store credentials in operating system in order to be able to maybe steal them if you are on a bad side of the road, or use them, or at least be aware, maybe change them, fix them if you are working on the good side. So whenever we are thinking, of course, about credentials in operating system, it is important to mention that lots of things in operating system that are well, maintained from the server perspective, not from the user perspective, they are protected by something that we call a boot key. Boot key is a value that consists of the class names. So we've got a data, GBG, JD, and SKU1, and we can pull it from the registry. Of course, if you are thinking that, oh, I'm just going to open registry editor and I'm going to take it out, that's impossible, because we are here describing class names, not really the values of the keys. So you need appropriate tool for that. It's like a description within the database in SQL Server. Yeah? And that boot key protects a couple of things that you see over here. Yeah? Starting from the green one on the top, we've got, for example, some database. So some database, we all know that it contains hashes. That is something that is on the disk in encrypted stage. So in Windows, for example, we use MD4 for passwords. Some people say MD5. It's MD4. We can calculate that. But this value, this database, it is actually also additionally encrypted indirectly by using something that is called the boot key. What brings us to a very nice conclusion over there already, that anything that you have access to offline, and when you got access to the system hive, you are able to decrypt the values that are mentioned over here. Yeah? Now, one value is very specific, and let's start from the difficult level, since we've got only 45 minutes. You are here. Hopefully you are ready for the technical ride. I am. So let's dig in. Yeah? So we're going to start from the most difficult one, which is the cache logon data, or something that we popularly call cache credentials. And we call this technically as well MSDCC2. Yeah, so this is the value. It's not like a very sexy name, but that is actually the value of the cache logon data in the registry. So what is this? So this is something that we've got in security hive, in cache, and the question, of course, is, are those credentials safe? And answer is they are pretty good. At the very beginning, let me explain this a little bit, and then I will show you a little bit of a demonstration around them, yeah? So what is important to look at on this slide is something that we've got in the left bottom corner, Microsoft implementation. So MSDCC2, yeah, it's nothing but a function which we shouldn't really care about the name, but this function PBKDF2, it is actually used by various types of password managers, things like Keepass, things like LastPass, Vault, and stuff like that. It's a pretty good function that leverages a couple of components that at the end, when we store the value like this in the registry, we can be sure that it's not reversible, that's for sure. Is it breakable? For sure, but it just takes a long time. If we have a look at what kind of components we've got, one of those components, it's something that is called DCC1, and this is something that I would like to explain. So it used to be like this. Yeah, in Windows XP, basically, we had cache logon data that was a little bit weaker than what we have right now. That's why you've maybe heard of in the past that if you've got cache credentials, cache logon data that could have been hacked, totally, because if you had rainbow tables pre-generated for the username, user's passwords hash, and on the top of that you calculate MD4, so it's like a double rainbow table, then this is exactly DCC1. But now, DCC1 is actually a part of the components that are technically getting into the PBKDF2 function. Yeah, so question is, are cache credentials or cache logon data safe? Answer is rather yes. But you wouldn't be there and I wouldn't be here if there wasn't anything interesting to talk about. So now, of course, it is like that. We've got Windows Vista and 2008, and since then, we are changing the cache logon data. So we've got MSDCC2 that we already mentioned. The only difference is the algorithm that is used. So here we are using AS128, but at the end, don't get me wrong, who cares if this is all encrypted by the boot key? Yeah, boot key is grabbable in a clear text in a registry. So if you are doing the pen test and you are stealing something from the server and then analyzing it locally on your machine maybe, what is important is to get the system hive and security hive, depending on what kind of secrets you would like to have, but system hive is the one that pretty much contains the most important information per server. Now, when we are discussing this logon data and so on, you can make it stronger. So it depends really who do you work for. Yeah? If you work for a military organization, you may want to store cache logon data in an even more complex way. So by default, the amount of iterations within the function is 10,240, but you can double it. Yeah? So that's pretty cool. Of course, that means you've got a little bit longer logon time, but it's not much longer in current time. Yeah? So this is the value that we can allow ourselves to set. In general, if you don't have any particular interest in that, just leave it like it is. So let's have a look. What do we mean by cache logon data? Okay, and I'm going to combine my demonstration with another demonstration that is related with the data protection API for the credentials. So first, let me explain that, and then we're going to move forward to the demo, which makes it a very difficult demo, but let's dig in, yeah? So what I'm going to do, because if you store your password, let's say in the browser, or if you use Outlook and you save your password in Outlook, or any form of a saving password you use in Windows, question is, who encrypts it? Is it secure? Is it dependent on your user profile? Is it dependent on the system profile? Like, what is this, yeah? So in general, we could say that if there is nothing specially used, like for example, ASP core or PFX files and so on, we're gonna probably use data protection API in Windows. It's a great mechanism that allows us to encrypt our secrets, and it's a mechanism that relies on really two things. Yeah? One thing is your password hash. Second thing is on information stored in a domain. And this is what I would like to show you, yes, that this information stored in a domain is actually something that will allow you to do a little bit of a master of puppets in the whole enterprise, because you will get access basically to everybody's secrets, which is pretty cool. So let's move forward. So first demonstration is going to be like this. First, we've got over here Windows 10. And what's the flow? The flow is that basically I would like to get access to a user's tools. So we're gonna technically use for that purpose. Let me just go to the not to this but to the drive, and we're gonna go to the CQ tools, and we're gonna use for that purpose. Well, let me just do that. CQ tools. Here we go. CQ tools. Yep. And then let's go to the Chrome. And so Chrome Pass that we're going to be using, so this is the tool, so Chrome Pass.exe. It's a tool that you can use from or play with from Nearsoft. And it's a free tool that allows you to show you the passwords from, for example, Chrome. Yeah? And again, don't get me wrong, not a big deal. Why not a big deal? Because you protected that password, which means any other app can also have access to it. Another lesson learned for today, if you do use 7-zip, do you trust 7-zip? I mean, it's a question about trust, yes? Maybe. I mean, I bet you use it. Do you trust WinRAR? Okay. What about Protos Hacker? Do we trust those tools? Yeah? So the reason why I'm asking is because every single time you run the tool like that, this tool easily can get access to your credentials because they are all accessible by all the other apps. Let me ask you another question. Do you trust CCleaner? Here we go. Yes? Thank you. So this is basically the story here. For the reference, CCleaner was brought to users with malware, yeah, by accident. So what we're going to do? So I would like to show you that when we, for example, play with the cache logon data, and I would like to do it in a very nice way, we will be able to, or not able to, get access to the user's secret. So at that certain place, I would like to show you first one thing, that if I want to log on to Freddy Krueger's account with password, yeah, I'm logging on, okay? So we all saw it, what's the password? So let's right now do the cache logon, which means that, let me, for the simplification of this demonstration reboot, we could do this online, that's, I mean, like live, that's not a problem, but I will do this offline to make sure that we are all clear that this is the cache logon data logon, yes, and we're going to be updating these types of credentials, yeah? So let me just boot, and in the meantime, what I'm going to do, I'm going to go to settings, and basically I will change the network configuration, and I will change it from the adapter, from not connected, from internal to not connected. Next, repair your computer, and then we're going to move forward to troubleshoot, advanced options, command prompts, and skip this drive. One of my drive is BitLocker, and then we are all good here. Now, unfortunately, I have no other impact here, so let me just increase the font so that we see of what's going on. Everybody can see that. Good. And I'm going to go to my tools. Here we go. And let's go to the CQ tools. And I got over here QE Secure Edition, and this is Mimikatz. You might have seen it, heard of it, and so on. We got a chance to cooperate with Benjamin. This is our version of Mimikatz. Our version of Mimikatz is not recognized by absolute vast majority of antivirus companies in this world. Yeah? And it has a bunch of additional modules. I'm happy to share if you drop me an email. And you don't share it with antivirus companies of this world. So let's move forward. So we're going to do LSA dump. Yep, perfect. And then we're going to do cache. And then we're going to override cache logon data. So we're going to do it in this way. So D, Windows, System32, config, and then system, and then D, Windows, System32. Unfortunately, I cannot tap over here, yeah? So config. And then we're going to do security, because this is where the cache logon data is stored in a cache folder, yeah? By default, we can save 10 cache logon data. Every single time user logs on, this data for the particular user is being overwritten, yeah? So why am I referring to this before we move forward, yes? Because in some security guidelines, you can find information, oh, don't set up cache credentials for like 10, just change it to 1. What's the point? There's absolutely no point in doing this, because they are not reversible. And to crack them, you really need to struggle. So it doesn't matter. Plus, even though you set 1 or 50 or whatever, there is still someone who can create additional value in the registry and say, I'm going to log on with the value that I create. And that's exactly what we are doing right now. So what I will do with the QE switch, enter, I am overriding all the cache logon data that technically was in this particular machine. So I got, for example, Blee, and I got also Freddy. That he's going to be the target. And over here, I overwritten these values with my pre-generated value. This is basically part of the research that we did in the reverse engineering of the data protection API. We reversed it all, actually, at the end. So anything that is relying on it, we are able to get access to. And just after that, we're going to be talking about Keepass, yes? So stay focused, and let's move forward, yeah? So this is good. We have overwritten cache logon data. So let's just close this, because our job is done over here. Continue. And then we're going to not boot like this. Now we're going to boot normally, but don't forget that we are actually logging on with the cache logon data because I have disconnected from the network. Yeah. So this is good. The reboot is actually pretty fast. Good. Now I will try to log on with the password. Try to. Yeah. So as you see, basically I've got password, enter, then it says it's incorrect. Good. Now I'm going to type another one, and this password this time it's called Mimikatz, and then I'm logging on as a domain user. Please notice it's not a local user, it's a domain user. So I'm logging on to the domain user with a different password. Of course, you might be wondering, what if I connect to the network? Will I have the credentials updated? Of course, because this is a cache logon data. But the point is, can I, at some point, get access to these secrets that we were just looking at? Yeah, so this is the combination in between cache logon data and the data protection API. And basically, yeah, this is my AMSI that I'm testing, actually. Here I've got searches through different types of master keys, and these master keys are, as we mentioned, encrypted with the user's password hash or a value from the domain. So with my password hash, which is Mimikatz, which is not known to anyone, I couldn't get access to any of those master keys. That's why I'm not able to get access to those credentials. We could be like, oh, that's pretty cool. It means that offline, if someone steals your laptop, this person would be able to get access to system secrets, but will not be able to get access to your secret. Is it really like that? Let's move forward, yeah? So, let's summarize. Yeah, so all these secrets, basically data protection API secrets, are protected like this. We don't need to know this by heart. You're going to get access to this slide later, so I'm only keeping this for the reference. But data protection API that we played with right now, it's also affecting credhist file, so your credential history that is maintained in every user's profile in the domain. Let's dig into extracting those secrets. I want to know this password of the user. I want to know what was it. How can I get it? So here's the thing. And this is part of our data protection API research and the tools that we are sharing on our blog. Yeah? So whenever we've got a client, and that client is connected to the domain, every single time I'm encrypting my secret, or I'm storing some kind of a secret using data protection API, there is one key that is always used. And that one key, it is actually placed in the user's profile. Yeah, so let me show you where we are able to find it. So in the Windows 10, if we get into the user profile, so let's get in here, and we're going to do %appdata%, we are able to go to Microsoft, and then we can go to Protect. There is a folder with the SID of the user, so let's go there. And I've got plenty of master keys over here, but what is important to show you is this. Yeah? This BK secure. This BK secure, this is the public key that is used to encrypt every single master key that you use to encrypt your secret. You're following? No? Okay, let me rephrase this, because this is actually a pretty difficult subject. These guys here, yeah, we should call them master key containers. Each of these entries contains two keys. 1, 2. Yeah? One is actually encrypted with the user's password hash, and one is encrypted with the BK secure. Yeah? This is the case. So each of these files contains two keys. Why do we care? You care because question is who can get access to your secrets. And when we mention user's password hash, I have to mention one more thing, that in a domain it's MD4 if it's a domain user, but if it's a local user it's SHA-1. Why? Because if you get access offline to the user's computer, you can extract the hash. Then data protection API wouldn't be that secure. Yeah, so first you have to crack MD4 and then calculate SHA-1 and then get access to these secrets. Yeah? So this is a little bit of an explanation. Now, question is, where's the private key? And this is what we move on with. Yeah? So private key, it is in the domain. So when we have a look at this picture, the client, when for example, domain admin, let's say, changes the password of the user. Yeah, Active Directory users computers, right-click reset. Yeah, what do we predict? That user will lose access to its secrets or not? We could be like, no, it will not. Yes, because what's happening is that there is a call made to the domain. Yeah, so when the admin resets the password, this BK secure private key, is responsible for decrypting or re-encrypting those secrets so that user can enter the new password. That's why if you type in MSDN search logon type, you're going to find a logon which is called new credentials. Yeah, we call it interactive logon, but this time it's not an interactive logon, it's a new credentials logon, because your secrets, when your admin changes the password, are re-encrypted so that they're not gone. So let me explain and show you how it works in a practical meaning, okay? So classic data protection API and getting access to the user secrets from the domain. Lovely. So what we're gonna do, we're gonna run technically one tool. We have simplified it as much as we could. We couldn't simplify it more. So CQ Elsa's secrets dumper. This is our tool that allows us to extract something that we call a golden key from the domain. So this, as you see, has a form of a PFX, which means there is this private key that we need. Question is, who do we need to be in order to be able to do that? And to be fair, absolutely, yes, you need to be member of the domain admins group, you need to have access to the ntds.dit file and the system hive, or you need to have access to the backup of the domain controller files. So these are the preconditions for getting it. Or you have to be a bad admin that wants to know everybody's secrets, which is also possible, yeah? So let's extract this. And as you see, well, we managed to get the, in this case, exported PFX. And this exported PFX, we take to the user's machine. I already did that, because scoping, it's not very fascinating. So at that certain stage, we're gonna be getting access to the user's secret from the user's perspective. So please have a look. This is the same Windows 10 that we've played with. I opened the console. This is a console running as Freddy, just to show you that I don't need to be an admin for that, because these are my secrets, so Freddy is not an administrator at all. And this is also the situation where domain admin has access to the roaming profiles of users, because your secrets, your master keys and so on, master keys are in roaming profiles. Secrets, it depends on the application, but most commonly it's actually that they travel together within the roaming profile, yeah? So it's just enough to grab the roaming profile of the user. So now what we're gonna do, let's go into tools, or actually CQ tools over here, data protection API, CLS. What do we need to do? Now this is the most complex thing today. We need to take this PFX, decrypt one master key from the master key container, encrypt it with our passwords hash, and then probably we should be able to get access to this particular secret that we stored in the master key. Now the big question of the universe is which of these master keys, because there's a lot of them, is the one that is actually used for that particular secret. Again, this would take a little bit of time, but each of those data protection API blobs that are encrypted within the Windows cryptography, they are always the same. They have pattern. So what we have written, you can download the tool from our blob. It's called CQ Data Protection API Blob Searcher, and you can run it on your server or your client machine, and it will show you all the data that has been ever encrypted by the data protection API in Windows, and you can have fun with all those secrets, yeah? So basically, just download the tool. It's super simple. Run it overnight, because it actually goes through all of the contents of the files, yeah? So, of course, as you can see, I'm testing with one key, yeah? So this will be probably this one, yeah? How do I know? Every single time you open the blob in the master that's encrypted, there is an identifier of the master key. So you search by that identifier. If you drop it in some kind of a hex editor, then you will see basically that they are patternized, and there is a certain moment where the master key identifier appears. So it's not that difficult to find it, yeah? So what I will do, I'm gonna take this buddy, shift right click, and then I'm gonna do copy as path, good, and I'm gonna be leveraging it here, yeah? So let's play. So first of all, I have to generate my hash, yeah? So CQ hashcalc, Mimikatz is my password, Freddy Krueger is the user. It's not necessary to give it for MD4, of course, but for MSDCC2 it is. So I just gave it both. This is what we're gonna need. Now, next thing is that we need to use another tool, which is the core tool over here, which is called CQ Master Key AD. This is the most important tool in our toolkit. And again, we could be wondering, why am I showing you the tools from our toolkit? Because that's the only tool that we know that exists in that area, yeah? So that's basically why, yeah? So it takes 3 parameters. that are important for us, PFX, file, and new hash, which explains what we were talking about before. Yeah, so in order to decrypt this secret, we need here to specify PFX. So let's do that, exe and then PFX. And then we've got exported PFX. Then we specify over here file, and this is what I have in my clipboard. And then we're going to specify this new hash, which is this value here, yeah, just to make sure I copy it well. And we're going to put it on at the end. So we got it here, we're going to do new hash and paste, and we are good to go, yes. Perfect. So what happened is that this tool creates as additional key. It's called AD modified. So what I will do, I'm going to take this body, rename, and then we're going to create it as good. Okay, and then we're going to take this AD modified, and again rename it, and then we're going to remove this name because we don't need it, obviously. This one, yep. And one thing more, yeah, because you probably notice, especially if you're sitting in the first rows, that this file, it's not having a system attribute, so we have to technically add it, yeah? So why like that? It's kind of strange, actually, but Data Protection API will not be able to treat this file as a valid file if it didn't have that kind of attribute. Okay, so why don't we just add this? So our tool generates a command already that is ready. This is this one. And we're adding to this particular master key this attribute. So let me just run this, and then we've got it, enter, and that's it. So this attribute has been given. We can come back to our Chrome, yes, and question is, can we get access to our secrets from the domain? And answer is yes. Yeah, what's the conclusion? Conclusion is that in the enterprise organization, your secrets are as safe as your password is, so from the user's perspective, or as your domain admin is. It's a little bit dodgy, don't you agree? How safe is your domain admin? Oh, I'm the domain admin, I'm safe. That's perfect, yes, because then you can get access to all of these juicy details, yes? And do people store passwords in their browsers? Of course they do, yes? To Facebook, LinkedIn, all of this stuff. Outlook, you got it all. Because Data Protection API, this is what is a platform in Windows. And don't get me wrong, it's a great platform. But if the golden key is in wrong keys, not keys, but hands, then of course we can have a little bit of a problem, yeah? So just to give you the clue of what happened, yes? So this is our way of retrieving the golden key from LSA. We are actually doing this in two ways. Yeah, we've got two types of tools that we are sharing with everybody. One is the CQ ELSA secrets dumper that I use for this presentation, but another tool that we have as well is actually directly grabbing this from the domain controller's memory. Yeah, so this is the story. Let's move further. So Data Protection API taken a little bit farther. Yeah, so what we're going to do? We're going to play with Keepass. But before we do that, a little bit of an explanation so that we've got it all. So when I was mentioning this Data Protection API blobs, and I was saying that they are patternized, so they are the same, we can actually see that over here. So this value here, so this header here, yeah, this is something that indicates that there is a Data Protection API blob starting, yes? Now, whenever we also have a look at the decoding over here, and again, on our blob, we share template for different types of hex editors that will allow you to identify what is actually a Data Protection API blob and what is not, yes? So if you run it through our template, you will see, and please have a look at the top fields, there is something that is called struct GUID, master key GUID, yeah? So this is basically identifier of this master key that you need to use from your profile, yeah? So this is how we are able to search for that. So let's get into Keepass and find out what's the problem, yeah? So Keepass, in general, consists of a database, and on the top of a database there is a bin file, and this bin file can be protected in various ways, as you know, because you use Keepass and other solutions, yeah? So one thing, it could be integration with the users, with the logon to Windows. Second thing, it could be your password that you have in your head, etc., etc. We are here referring to one type of a protection, when you rely on a Windows logon. So single sign-on to your secrets, this is basically the situation we are describing. So let's dig in, and let's have a look how we are able to get access to the Keepass database, okay? So what is the situation? The situation over here, and I'm bringing the machine to the field, is that this is an admin that user was fired, but apparently user had some kind of a Keepass database, and we would like to get access to this Keepass database. Yeah? And user relied this Keepass database on the Windows logons because this is what typically users do. Another password, it's not often an option. Yeah? So we grab this database, and what do we have over here is that particular database and the protected user key bin, which you get from the roaming profile of the user. Yeah? So this is basically the story. Now, if I try to open this particular CQ base, and I try to, and I will show you because we're going to be using this password, type password secure, and I will just uncover it. Yeah. So as you see, this is basically secure, and I will press enter. Yeah. Then basically this doesn't work. Yeah, because this is not the password to this particular database. Okay, so point proven. Yeah. So we can close this up, and then it's just like an empty database. Now our job would be to get access to this particular database by decrypting protected user key bin by having the decrypted master key of the user. So it's like previous scenario, but we are in the middle of it now. So I took the golden key from the domain, decrypted a master key of the user like we did, but this time I did not re-encrypt it, but I'm keeping it raw to use it for the decryption of the protected user key bin so that we are able to decrypt the database. Yeah, so this is the flow. Good, let's move forward, yeah? So we're gonna do it like this. I got here two tools. CQ data protection API blob decryptor. For every single blob that you're gonna ever find, you can use this tool for. So this is the one, and it takes a couple of entries. Master key entropy blob. Entropy, what's this? Master key we know, blob we have, that's it. What's the entropy? Here's the interesting part. Some solutions in data protection API, they actually use entropy. What is the determination if they use like entropy or not? Just like that. I want to use entropy. Tongue. So Keepass actually uses entropy. What else uses entropy? Transparent data encryption in SQL Server. Even though it relies on a system data protection API, it still uses entropy. What about the other solutions? Rather not. It's actually quite rare, but Keepass does. So where can we get the entropy from? Well, entropy must be saved somewhere. It must be available somewhere. So either we ask Keepass to give us an entropy, which we've got an API for that, or in the case of a SQL Server, you go to the registry and you literally copy the value from the registry. Entropy is nothing but additional value that's supposed to make the whole encryption a little bit more stronger, yeah, in a short words. So let's dig in. We've got CQ Keepass decryptor. We've got always these weird names for these tools. I'm sorry for this, but we've got so many of them that the names have to be descriptive, even though they are absolutely bad, so that we know what this tool is for, because then you've got this 20 tools and you're like, what we were doing, yes? So that's why. So this value over here is the one that we're gonna use for the entropy. So let me copy the whole thing, and then now we are like 50% done, yeah? So we're gonna decrypt the blob first. So the previous tool, blob decryptor, and as you remember, it takes master, entropy, and blob. Okay, so let's do that. Master, and master we're gonna copy, or maybe let me start from entropy, because I have it in my clipboard. Master key I have already here decrypted, because otherwise I will need to repeat the previous demonstration, which would be pointless. So let me just copy this, paste, and then we're gonna do another one, blob, where we've got it in C, analysis, and then we've got protected user key bin. Okay, thank you. So what this gives us, it's a decrypted protected user key bin. This is this guy here. What is this? It's actually a key that you guys use to decrypt your Keepass database. Bring it on. So now we need to find a way to decrypt the Keepass database. Yeah? So for that purpose, we're gonna use Keepass tool. Yeah, you don't need to know how to do that. We actually spent quite a long time on that, but who cares? Yes, at the end there is like one little tool that we're able to use. And this takes two parameters, K, so for key, and then F for file. So let's do that. We've got a key, bring it on, and then we do file, and then C analysis, and in this case it's a CQ base KDBX, lovely, lovely. C analysis, CQ base, and so on, KDBX, perfect. So let's get into this particular folder. There is this file, which is our decrypted database. And as you can guess, I'm typing here the password secure because this is what our tool does. when it decrypts the database, it actually puts the password on it, so that it's not like available by everybody. And then when we do OK, then it opens it, and then eventually we're able to get access to someone's Keepass database. Yeah. So this is the flow. OK, not very positive, isn't it? Yeah. But anyway, so what's my point? It's as safe as your password is in a domain, and is as safe as your domain admin is. If your domain admin will eventually fetch the key that we are talking about, that we call the golden key, this person is able to get access to everything that you rely on your own credentials. Does it mean it's a bad platform, as I already asked? No, totally not. And I will repeat it again and again. Data protection API is amazing. It's just that it relies on different areas that we have to protect. Yes, nothing new, but we have to protect our domain controller and trust our domain admin. That's also nothing new. Okay, so let's dig in. So this is the Data Protection API classic. Yeah. What about Data Protection API for system? Yeah. So how do we get access to these system secrets? Let me give you one example for that. That is actually quite straightforward. We've got an IIS. IIS, so it's a web server. In IIS, we are able to configure different types of passwords. For example, for application pool identities. For example, for private protection of the password of the private keys for the certificates that you use. These are the major entries for those. So who really is capable to decrypt these values? And answer is very, very simple. Windows Process Activation Service. Windows Process Activation Service, that's the guy, and I would say the name stands for itself, that activates some kind of a process. And that process, it's nothing but worker process. But in order to be able to operate on a worker process, it needs to get access to application host config file. What is inside? Inside application host config, we find encrypted passwords for application pool identities. So this is a very simple case, yeah, because it's also very straightforward, and let's dig into this. So if technically I'm going to get into Windows, and then system32, system32, okay, inet srv, and then config, and then notepad application host config. Yeah, I got over here configuration of the application pool. Yeah, and it's running on Freddy's account. Normally we have application pool identity, so it's an identity of itself, of it's an application pool's identity. But this guy over here, it is saying that it's encrypted. And it even says how. And it's symmetric. It says IIS, Windows Activation Service, but wait, I just said Windows Process Activation Service. Somehow someone was hungry and has eaten letter P. I mean it, it's kind of funny. So a Windows Activation Service, only AS provider, yeah? So we've got a symmetric cryptography, and this value over here, of course it's a little longer, it is encrypted password of Freddy that someone put in the IIS configuration. So quite easy. Let's dig in, and let's find out how to get access to this. But before we do that, a little bit of more explanation. So Windows Process Activation Service can read it. But it doesn't read this blah, blah, blah characters, yeah? It knows how to decrypt it. Why? Because it's a system secret. So if I'm supposed to start the process with some kind of identity, so as Freddy Krueger, obviously I have to be able to decrypt this password. Yeah, we're not talking hashes here, we are talking symmetric encryption. So let's have a look how to do that. And that is actually quite an easy thing, yeah? Because why should we create our own tools if we can just ask operating system for that, yeah? So let's do that. For that, we can use appcmd, list app pool, app1, yeah? So this is basically the command for listing application pool settings, text, and then asterisk, and then it gives us an output for the application pool configuration, yes? And if we have a look closer, then we can easily spot that one of the values that we are having over here, it's the password in a clear text. Again, symmetric encryption, yes? Of course we can decrypt it. Every single time, let me put it this way, when we store some kind of a password in a configuration in an operating system, don't even think it's hash. It's not. Someone has to use it. Password is only stored in the form of a hash in some database or ntds.dit, and some kind of form of a hash in the cache logon data. Yeah, so this is something to have a look at. Now, whenever we are thinking about these particular decryption. Yeah? So one more thing per system. Yes, it's also the same story when we think services. Yeah? So this is a very simple case. So in a case of services, when you configure the service account, of course, someone, and in this case, service control manager, needs to take this identity and run the service as this user. Yeah? So as simple as it is, and we don't have to search for long. So let me get into the demonstration over here. We're going to get into, just let me move to my folder where I have my tools. So we've got to be administrator and desktop, and over here we've got tools. And I've got a tool that is called CQC Creds Dumper. This is a very straightforward tool where we give a name of the service. And then if we do have a service that is running as a dedicated user, so I got Paula's service running as Freddy Krueger, so I can specify here PJ service. Yeah, and of course this password comes back, because this is something that is relying on the system's data protection API. It's as safe this time as your offline protection is, and it's as safe as whoever is admin on your workstation or on the server. Yes, so this is basically who eventually, and it's not a rocket science, has access to the boot key, because this is something that allows you at the end to get access to all these secrets. Yeah. Okay, good. Now, very, very last thing to dig into. That is basically related with the data protection API and G. And this is a very cool subject, because it's no longer data protection API classic, it's a new generation. This is something that has been digested in Windows Server 2012 R2. I don't know if you use this feature, but maybe you should have a look at it, because it's actually pretty cool, which is called Sid-protected PFX files. Now, Sid-protected PFX files finally provide us a functionality of having a PFX that can be opened by people that we say, just because they have this SID, and that just because we've got this KDS root key in the domain. I mean, funniest part that happened during the pen test, I have to share with you this story, is that one of our team members is doing the pen test, and we are like talking on a chat, you know, like very nice day, we have a very close relationship with everybody in the team, and he's like, hey, I found a PFX, what do you think is going to be the password? And it was a root CA PFX on one of the servers. Yeah, so I'm like, I don't know, type letter A, and he did, and it was the password, and we're like, silence on the chat. Yeah. How could it be? Yeah. So I know that passwords for PFX files, it's something horrible, but I would like to show you something. Every single time we protect the PFX file like that, so let's dig in. So I will show you the case. We can choose, of course, who do we want to participate in having access to this particular PFX. Yeah. So I'm just authenticating to the machine, and then I will show you the case. So I've got this particular user here, and I can export, so do all export, yes, next, yes, to export the private key, why not, we need that, okay, next, and this is what I'm talking about. Either you put the password on you, or you say, I want Blee to be able to get access to this file. Okay, thank you, next, and then we save it, for example, Blee. So we've got Blee, let's do a test, for example. Yeah, so this is my certificate over here. And this particular Blee, yeah, can be opened by Blee too. But what I want to show you is actually quite interesting, yes? So we've got our Blee test. Yeah, this is the one. And we do next, next. And because I am Freddy, who prepared a certificate for Blee, don't forget, PFX, it's such an old school file format. Regardless what kind of protection do you layer it on with, it's going to be always like this, and you'll be always able to see the password. Yeah. Now, question is, of course, where we are able to see this password, and answer is in a pretty much similar way as we had before. Yeah. So we are able to fetch this by technically getting into the domain, eventually copying some data from the domain, and then being able to decrypt it. Now, how do we do that? So let me show you how I will be doing this on this particular example. Yeah. So what I used for that, let me just get into the decryptor tool. Here we go. I'm going to get over here to the D tools. So we've got a D. This is my toolkit again. So we're going to get into tools, CQ tools, yeah. And I have over here a couple of things. One of the things that I posted over here, it's basically, in this case, NTDS. So ntds.dit, it's actually the one that I copied from the domain. We need this. And another part that we will need from the domain, it is actually something that we call a KDS root key. And this KDS root key can be grabbed by the well, different types of toolkits. So this is the one set that we need. And another one that we need over here is actually the boot key. Yeah, so there are a couple of things that we can use for that purpose. Yeah. Now, whenever we are thinking about the whole flow of the demonstration, so when we get into the tool, we've got over here CQ, DPAPI, and then we've got blob, not the blob decryptor, but PFX. Sorry, PFX, CQ, DPAPI, PFX. No. PFX decryptor. Okay, let me just get into the folder. And then we've got the tool, PFX decryptor, this is the one, and this one takes into consideration two things, PFX and master key. And in this particular scenario, in order to be able to fetch the master key, yes, we need to get into our toolkit, yes, and for that we've got CQ NTDS decryptor. And CQ NTDS decryptor, oh, let me just grab this again. Sorry. I'll just get here. Maybe just one thing. CQ NTDS decryptor. Okay, good. Yes, we're going to specify the boot key, the file, out file, and so on. So in this case, we're going to technically get this master key. So let me just run it. So once again, CQ NTDS decryptor. And here we're going to do boot key. And that boot key we grab from the domain. So this is the one that we have. No, not this one. Just let me just grab this one. Yeah, I think the easiest way would be if I copy this value, but no, but this is not. No, let me just fetch it. CQ secrets dumper boot key. Yes, so this will be the fastest way. Okay, let's grab it. And this boot key that I was mentioning will be basically going over here. So we've got a boot key, we've got a file, ntds.dit, yes, and basically we can specify over here that we would like to do KDS root file, and this KDS will be the file that we're going to be technically leveraging over here. Yeah, so in this case we're going to specify KDS, or just KDS. We can do that. KDS.dit. Yeah, that's perfect. Yep, this is actually perfect. Then we take this master key. And now we are ready to decrypt the value. So CQ, data protection API, PFX decryptor. Let's run this. Once more parameters. We've got PFX and master key. So we do master, ping, and then I'm going to copy from the client this particular certificate. Yeah? So let's do cancel, and this was this BLE test, copy. And I'm going to paste it in this particular directory that we have over here so that we are able to fetch it and eventually decrypt it, yes? And this will be our setup, yeah? So as you see, it's not that difficult to work with this. It's just really a matter of an appropriate tools. And I have already the certificate copied, okay? So this is on my side. And then we do PFX, and then we do BLE test PFX. This is the password. So let's check out BLE PFX. This opens the wizard on my side. Yeah, next, and Control V. Display passwords. This is the password. Next. Thank you. We got it. So this is basically how we are able to get access to Sid-protected PFX files. Yes. Is this a safe mechanism? Totally yes. But again, it's as safe as your domain controller is, and it's as safe as your domain admin is. In the case of a data protection API system, it's as safe as your offline access is, and it's as safe as all your admins are that are able to log on to the server. So this is basically the conclusion, yes? We've got two ways of storing credentials, or eventually three, yes? So one, data protection API in general, and hashes, but the data protection API divides into two parts, which is system and user, yeah? Domain admins, absolutely crazy important role. If you got a possibility to monitor them, please do. And in general, please do not forget that data protection API, it's a very safe mechanism in Windows, but it is as safe as its own surroundings. So this is basically the flow. One more thing at the end. Don't forget, we are running on our blog a quiz. This is a quiz 2.0. Just started, 25 hardcore security questions, free, no registration. It's a great learning tool. If you feel that security is juicy, this could be the place for you to do during the break time. Thank you so much.